Alright, it looks like you guys caught me. Well, while you're here, let me explain Physics C 1982 problem M3. Now in this problem, there are two masses connected by a massless rod that's centered about point P. Now one mass is 2m, or it has a mass of 2m, and it's a distance of L away from the axis. The other mass has a mass of m and is a distance of 2L away from the axis. Now the first step of this problem requires us to find the angular momentum. Now the sum of the moment of inertias times the angular velocity gives us 6 ml square omega initial. Now the second step of this problem requires us to find the frictional torque acting on the system about the axis for point P. Now this is simply going to be the sum of the torques acting on this system. So you have a torque on this first mass and a torque on the second mass. Now since both the torques are going to be slowing the system down, let's have them as negative, and in fact let's make that correction here. There should actually be a parenthesis. Okay, now once you solve this equation, you get down and you get that the sum of the frictional torque on the system is negative 4 mu mlg. Now, step C in this problem requires us to find the time t at which the system will come to rest. Now, it's very easy to solve for this because we know our equation is torque equals change in momentum over change in time. Now, since we want the system to come to rest, our change in momentum is going to be 0 minus L initial, because we want it to have 0 momentum at the end, and that minus our L initial will give us negative L initial. Now time initial is 0, so it's simply going to be torque equals negative L initial over torque over time final. Now you can change around the variables and solve for, or isolate time, and then when you solve, the negatives cancel out to give you a positive time of 3L initial angular velocity over 2g mu. Now this is the solution to Physics C 1982 problem M3. If you want another one, please comment. Actually, don't comment. I don't want to do any more physics today. I'll see you guys in the next one.